As Thornton Wilder's old fortune teller says, it is easy to tell the future, but ask who can tell the past. It's not just a memory problem, but one of too much complicated detail without enough perspectives. It would be great if we could go back there and take a look at the world Bonnie talks about. And to some extent we can. Some years ago, Xerox decided to clean their warehouse and throw out most of the Park data disks. Here's one of the few that got saved. About 100 out of thousands were rescued, and a few thousand files were recovered. And just one of all of those files happened to contain one of our systems from the 70s. Smalltalk is in the form of a software internet of software computers that is completely self-contained. There's no separate operating system, applications, etc., only software computers communicating with each other, and each simulating some aspect of the personal computer system. Some objects simulate characters on the screen, some simulate pictures, some windows, some places where the users can do things. The software computers are in terms of virtual hardware that is independent of the physical computers they run on. To bring this back to life, we emulated the virtual hardware, in JavaScript actually. It is faster than the actual Park computers of 40 years ago. And with this, we have a time machine that allows us to go back into the past and run the same software that both Bonnie and Steve Jobs saw. And in fact, I've been using this system to give this talk. Here we see something that is vaguely familiar, overlapping windows, iconic representations, and so forth. And this system ran on the three main machines at Xerox PARC, the Alto, the first modern style of personal computer, the Note Taker, the first portable computer, and the more powerful Dorado computer. Windows here are views of tools and the kinds of resources that media authors use to create the writings of the future. They are not apps. We can bring any and all objects in Smalltalk system to any of these projects. And we see here a view of the system itself, an animation, a halftone painting I did 40 years ago. I can scribble it up a little bit for you. Here's some text. The system also had a gesture recognizer. We can use this a little bit later for something that I think you'll like, but here I can use it as a way to reorganize this view of text. And there was the Whole Earth Catalog and its folks nearby in Menlo Park who were thinking big thoughts about universal access to tools. Not just physical, but especially mental. This was the first book in the Park Library, and it had a big influence on part of how we thought things should be. We loved the idea of lots of different tools being available with explanations and comments, and could see that it would be just wonderful if such media could be brought to life as one found and made it. This led to ideas about the next level of how to explain and explore by actually making things from computer stuff in the kind of general literacy we have for reading and writing, but now including the reading and writing of dynamic models. This kind of literacy is best learned by children, and so we started to work with them. Here's the computer version of an article that 13-year-old Marion Goldine wrote in Creative Computing magazine in 1975 about what she'd done the previous year in our group. The computer version goes beyond reading to allow the reader to try out the very things that Marion is talking about. We call this form an active essay. Right in the essay is a simulation of an Alto screen, so one can see what things look like when she did her projects, and doing the very things that she did. She started off by making a box object called Joe that can be sent messages to get it to behave. Programming in Smalltalk is a bit more like training intelligent agents than like the more standard metaphor of programming as being like a cook making something from inert ingredients. And now here's a wrinkle on a demo we used to do which combined animation and painting tools. The animation tool is animating the bouncing ball, and we can see that it's a bit weak. We would expect that the ball would deform when it hits the ground. We should draw a better cell for this frame. Now the animation effect depends on what the brain does when it sees two different images, one right after the other. Animators like to say that animation takes place in between the frames. This means that we'd really like to do the redrawing of the bottom frame while the animation is running. But these are different tools. If they were apps in a commercial version of personal computing, we would most likely expect that they don't talk to each other, and it would be difficult to get them to talk to each other. This is a pet peeve of Ted's. But here they are just objects, and any object can talk to any object. First, let's take a look at the menu for the animation window. We can stop it ticking, we can single step to the frame we care about. Now we want to share this frame with the painting tool. If this was prepared ahead of time, we would already be done, but that would lose the point of this demo. Instead, to paraphrase Thoreau, we need to find out what Texas might have to say to Massachusetts. That is, how do each of the tools characterize their parts and behaviors? Then we can do what Ted loves, is to draw a line between the two windows. Some of the actions could already be predefined, but here we want to define one. So we do this gesture to create a dynamic link between the two windows. And what we want to say here is that the painter's picture wants to be linked to the bouncing window's current frame. So we'll just write that in there and do it. Now we can start the animation again and start painting the deformed ball. And it starts to look pretty good. Of course, there's a lot more to show, but this is plenty enough for today.